What's up, guys? It is Matt from Matt's Math Tutorials back again for the second video of the week, or of the day, really. So, again, since I missed last week, I'm doing two videos today. Um, and so this one is also from my homework, from yesterday's homework. This is Calculus 8th edition, section 7.2, problem 13. So, find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the given lines. So this is one of those things where you start with the graph and then you like rotate the whole graph around the x-axis and then you may, or maybe the x-axis, maybe this, and then you create like a whole solid of revolution. So that's what we're doing right now. So we have y equals x squared, y equals 4x minus x squared, and the x-axis for A, and then for part B, the line y equals 6. So let's do part A first, of course. Let's draw a diagram. So we have y equals x squared. That's going to, of course, be something kind of like that, more or less. Okay, that probably wasn't even any better. So 4x minus x squared, that would be, let's see, factor out the x, 4 minus x, so it's going to be parabola with zeros at 0 and 4, and it's going to be negative because the negative's on the x squared. So it's going to be approximately like that. All right, that's just some rough numbers. So let's see. First, label some important points. These don't look like it, but they actually intersect at the origin. So I'm going to put a dot there in red, big enough to that it covers the whole thing, and my precision doesn't look as bad as it is. And then another one, they also intersect right here, because these two dots are going to be our interval for the eventual integral that we're going to make, because, well, it's calculus, area under curve type stuff. We're probably going to do an integral, right? So we know that that's 0. We don't really know about this one yet, but it should be pretty easy to find, right? You just set the two things equal to each other, right? X squared equals 4x minus x squared. Let's see. Get that on the other side. You have 0 equals 4x minus 2x squared. And then you factor out, it looks like factor out a 2x here. 2x, and then 2 minus x. So the zeros are going to be 0 from that x and 2 from that, or the zeros, which in this case are the intersections. So they intersected 0, which we already knew, great. And then add 2. So this is 0, and this is, looks like going to be 2. So a solid of revolution is when you have something like this, right, like this area. And then, if you can imagine this, I can't really draw it that well, but you kind of rotate it around this x-axis in this case, creating a 3D thing from a 2D cross-section, right? And so we actually have a formula for this, because of course, well, if you think about a circle, right? Sure. You kind of do a similar thing, right? If you take this line and then you rotate it across this whole thing, you create kind of what we're doing, but one dimension less. Maybe two, not one dimension less. It's the area of the circle is, of course, pi and then r squared. But we can do a similar thing here, actually. If we square, let's see. Well, I'm not going to get into specifics, but basically, we have a function or a formula for this. So we have pi times the integral ab of the radius, which is going to be, so if you had like, if you had something a bit more standard, right? If you had like uh this, oh, actually something like this, we're going to have the radius squared, which would be like this distance here, right? That would be like the radius. But in this, we actually have kind of two distances because we're not dealing with a solid, we're dealing with kind of a hollow type thing because we have something like this. By the way, this example is completely separate from the actual problem. I'm just kind of showing you what's up. So we actually want just this area to revolve around the whole thing. And so we want this distance, but we want to subtract this distance to find just, that distance right there. And so this is, we're going to think of that as like this is going to be big R, on the left and a small r on the right. So we're going to do minus r, small r squared. So this represents just this right here. Wow, that was pretty bad. Uh, r squared. So that represents just the distance, the actual distance here. Um, and so actually what we could do is we could just do minus, we could do dx minus this, right? But actually, because of some properties of integrals, we can actually just combine this into one thing, which is what we're doing. But that's really what we're doing, right? Because you could actually think of it as two solids of revolution, right? A solid solid and then a smaller solid solid, and you're subtracting them to create the hollow one, right? Um, yeah, I mean, it's hard for me to draw 3D stuff to give like good analogies, but that's kind of the idea of what we're doing here. So, and again, this comes from kind of this idea of taking a thing and rotating it around a circle. So we have this, and reminder, this is the first function and second function. And by first function, I mean the one that's higher up, because we want this whole thing, ideally we want that to be positive, or else it gets kind of weird, but not too weird, but a little bit weird, and we don't want that. So which function is on top here? That'll determine what order it's in the integral. Well, it looks like if we're going based on this y, on this x-axis, this parabola is on top, and that is the 4x minus x squared. So let's set up our integral. So of course the pi, right, from the equation that we had, and integral, we know our two intersections. It's from 0 to 2. And then we have 4x minus x squared, and this whole thing is squared, and then minus the other function, which is just x squared. But remember, it's x squared squared dx. Okay, so for integral purposes, don't really like the form that this is in with all the parentheses and the squared, so I'm just going to expand everything out. It shouldn't be too hard. I think at this point in my math career, I can do this pretty quickly. So that would be, and you should be able to too if you're taking calculus. And if you're not, thanks for watching the video, despite the fact that you don't understand what's happening or understood what was happening maybe a couple years ago. But yeah. Okay, I think that's right. So now, of course, these are going to cancel, so we're just going to have pi 0 to 16x squared minus 8x to the third dx. Okay, so now we can do a antiderivative. Of course, still have the pi out there, that's going to stay there. Simple power rule 2 times, we have 16x to the third over 3 minus, that's going to be x to the fourth, so I can actually do kind of a little shortcut here. Because otherwise we would do 8x to the fourth over 4, but that's obviously just going to simplify to 2. So we can just leave it as that, and then 0, let me do that again, 0 to 2. Okay, so we're going to end up doing, we're going to find it at 2 and subtract what we find when we do 0. But in this case, if we plug in 0, it's pretty obvious because there's no just constants, that the whole thing's going to be 0 if we plug in 0. So really we can just find the value of this at 2, and then that'll just be our value. So again, this shouldn't be too hard. Of course, this is only part A, so I'm going to kind of speed through this kind of quickly here. Yeah, if any of this is confusing, just let me know in the comments. I can try to like explain step by step, if there's something that I did that was kind of special. But I definitely didn't use my calculator for this when I was double checking earlier. Yeah. Okay, so this should all be pretty easy. I'm only speaking through this because there's two parts to this, and I want to get through it quickly. Okay, so this is the answer to part A, right? Because this is the integral of the thing, of the distance from here squared minus the distance from here squared times pi, right? Because of the rotation. And that is going to be the volume of the solid. So this is the answer to part A when we rotate around the x-axis. But for part B, we want to rotate around the line y equals 6, which is, let's just call it right there. And so for this, things get a little weird. Because in this, well, anyways, never mind. But basically, we want, instead of the distance from, let me do something a bit more noticeable here. Instead of the distance from, let's say here, okay, from here to here, right? Because we would want that distance, that distance, that distance, right? This whole thing, because that's kind of how integrals work. Instead of that, well, we do want that still. We still want this. Sorry, we still want this. But in the previous thing, what we did was we took this distance right here, right, from there to the x-axis, and we subtracted this distance right here. But now we want to go to the line y equals b, right? Because we're not going to rotate here. We're going to rotate here, right? Pretend that's three-dimensional. So we really want the distance, that distance, not that distance, sorry. We want the distance from the bottom one up here, because we kind of turn the whole thing upside down, and this top one to up there as well. Because, again, like I said, we're not looking at the x-axis anymore. In fact, we can pretty much disregard the x-axis completely. It has nothing to do with part B. We're just looking at this distance there. And so, if you can imagine, like I said before, the big R, the first R squared, is going to be the top function. But for here, relative to this line y equals 6, if you kind of like turn your head a little bit, the top function is actually going to be this one, because we want that minus this, right? We want, the bottom one minus the top one. I know that's a pretty confusing explanation. If it helps, you could also still think of it as the smaller one minus the bigger one, and then just saying that because it's actually below this line, you can just it's negative, but we want to be positive, so you can multiply by -1. You could think of it that way if you want, as like an absolute value type thing. It doesn't actually make a difference because, of course, saying a minus b is the same as saying negative b minus a, right? So in the end, it doesn't really matter. So whichever one's easier for you to think about, but basically, the effect is that we're going to end up flipping the order. But we also have to subtract 6 from each function because we want the distance not from the x-axis, we want the distance to 6. Because in these, right, there's kind of a hidden -0 here in both of these because we're going from the value of this, which is going to be somewhere on, this line, we're going from the value of this to 0, which is the same as just the value of this, but really we're taking that distance from there to 0. And so now since we're doing the distance from there to 6, we want to do -6. Or really, because it's a negative, the way it works out, it's going to end up being like +6. So maybe if I write down, just be simpler, because I know my explanation is not very good. And to be honest, I struggled with it too until I looked at the answer key as like to what they wanted me to do. I had the right idea, but it is somewhat hard to figure out. So our big R in this case is going to equal, right, we're going to look at this bottom function. So it's going to be, well, it's going to be the x squared, but it's going to be negative x squared plus 6, or, -6 times -1, whatever. In fact, let me actually write that our way. X squared minus 6, but of course that's going to end up being negative, so times -1, which is basically just going to end up being 6 minus x squared, a little bit nicer to look at. And then the r is going to be the 4x minus x squared, and then plus 6, but then times -1 again, which is going to be negative 4x plus x squared minus 6. And so we just are going to set up the integral same as before, right? We still have the same interval from 0 to 2. We still have the pi out front, and we still have the big R squared minus small r squared. It's just a few things are different here. But it's not too much that we can't keep track of it a little bit. So integral 0 to 2. So I said the big R is not going to be that one. So 6 minus x squared. 6 minus x squared squared minus Um, negative 4x plus x squared minus 6. Okay, squared and then dx. So basically all we did was instead of finding the distance from the function to the x-axis, we went from the function to 6. That's basically the only difference. And then the negative stuff is just it just has to do with the fact that um, these are entirely below the y equals 6. So if we did it regularly, we'd end up getting a negative number. But for this purpose, we want the absolute value anyways. So we just kind of multiply by -1 to make it work out. But basically, that's the only difference. Is just going from, instead of going from to 0, we're going to 6. All right. So this, yeah, I'm not gonna lie. This is pretty ugly. Um, Let me see, honestly, if there was an easier way that I did it. Nah, you kind of do just have to multiply everything out. The one thing that I did that made it a little bit easier when I actually did this for real in my homework, is I used the whole like uh a squared minus b squared equals a plus b, a minus b. Um, and I think that might have made it a little bit better. I'm not really sure, but might as well do it, right? And this is, we're just rearranging for now. We're not actually doing any sort of antiderivative stuff, so we're just going to keep this all in here. So a plus, so the a is going to be 6 minus x squared, and then plus the b is going to be 4x plus x squared minus 6. And this might make it look uglier for a second, but I think it does make it slightly easier. If not, whatever. It's just another way to do the problem, you know. Of course, distribute the negative, so minus x squared plus 6. Because this gets rid of the squares, but we're still gonna have to multiply a bunch of stuff out, so it's not like the most helpful thing ever. I acknowledge that. Um, and I think you might even be able to just put this one in the calculator. I don't know like if this is a non-calculator problem or anything. Um, but you know, who really cares, right? Well, these cancel out. Is that true? Oh man. Um, I think that is true. This one should. Oh right, this was supposed to be a plus 6. I had a plus 6 there. Um, oh, I see. So I have this wrong. This is how you know I'm doing it live and I don't like have everything completely planned out. So this, is there an easier way to do this? Problem is when I erase stuff, it just shows the background. It doesn't just show the white. I'll just do this. So this should have been a minus 6, basically. Yeah, minus 6, and then when it gets here to the negative times -1, then it should become the plus 6, right? Because this one was a positive 6 after the -1. But I had this one reversed. Luckily, pretty easy fix. That should be a plus, this should be a plus, and this one should then, of course, be a minus. You know, I could have just like, oh, that looks terrible. I could just do this. I don't know why I'm not just doing this. That's much easier. Okay, so this one should be a minus. Hopefully this shows you it's okay to just, you know, make mistakes sometimes. You got to do like a check sometimes, because I was thinking, my thought process there was if this was a -6, then this would cancel out with this, and this would cancel out with this, and that felt a little bit too easy for a problem like this. And also I don't remember it being that easy on the homework, so I kind of like realized something was wrong there. And you know, my intuition for that sort of thing might be better than yours. Yours might be better than mine. You know, it's kind of one of those things. You can't. It's hard to teach that sort of thing, I guess, except for if you just do a bunch of problems. But the x squared still cancel out, which is nice, but it's not as nice. Does anything cancel out over here? Let's see. No. Oh yes, the sixes cancel out. Okay, I'll take it. If you can get anything to cancel out, that's a win in a problem like this. Let me just. Yep. Okay. So I do have my notes pulled up from when I did this problem, which is what I'm checking this against. Okay, so this is all of a sudden not as bad, I think, as it was before, but maybe, maybe I didn't really save any time here at all. But just gonna expand this out. 12 plus 48x. Oh, that looks stupid. Plus 8x to the third minus 16x squared dx. And so now that we have it in a form like this, we can do finally the antiderivative stuff. So it's going to be negative 24x, because this is just, at this point, it's just 4 power rules. And you always want something that's going to work out that easily, right? Plus 24x squared plus 2x. No, these work out kind of nicely for some of them at least. Not the first and last ones though. Oh, I can combine these actually. Though, why didn't I do that when it was in easier form? All right, let's see. So negative 24 minus 16, is that what, negative 40? 40 x to the third over 3. And then the rest of it you can't really combine. Plus 2x. Okay, so now again, when we evaluate it as 0, it's just going to be 0, the whole thing. So we can just find the value of this at 2 and call it a day from there. So pi, okay, negative 40 times 8 over 3 plus 24 times 4 plus 2 times 2. Okay, so do I want to do this in the calculator? Yeah, kinda, to be honest, but I'll persevere and just hope that I get it right here. Let's make these all over 3. What's 24 times 4? 25 times 4 is 100, so minus 4, that'd be what, 96? What's 96 times 3? That would be, let's see, what, 300 minus 12? Sure, let's go with that. I don't know. And then for 12 over 3. This feels wrong. I think I did something wrong here. But that's good. Sometimes you need to do something wrong every once in a while. Yeah, because here it's plus 288 plus 12. Oh. Yeah, okay, so this would end up being negative, which is not exactly what we want. So where did I go wrong? Oh, I see. I think this is wrong. The 2x. Where'd that come from? Aha, it should have been 2x to the fourth. I see, because I did, yeah, okay. To the 4, to the 4. Okay, so now, instead of 12, this is going to end up being, what is 2 to the 5th? Anybody know? I don't. 32, I think, right? So, that would be, what? Yeah. The 2 to the 5th is 32, and then 32 times 3 is 96. Okay, so now this problem just can do on my calculator because I really don't feel like doing all this arithmetic. I'm not gonna lie to you. So that would be, I don't know why I wrote that. 64 pi over 3 because these add up to 64. This is still the 3. You can't really simplify that. So this is our answer for B. So what was this again? This is the solid when you rotate it. When you rotate this area, that area, around line y equals 6. Okay, so that took a while, a lot of mistakes, but I mean, I don't know. People think being good at math means you just do a bunch of arithmetic really fast without getting anything wrong, and that is not what being good at math is about. Being good at math is, I don't know, about like creativity and just, persevering, even though you get stuff wrong a bunch, because it happens to everybody, and I'm no exception to that. Even though I have a math YouTube channel, I still make mistakes. So I believe this answer is right. Let me just double check. But yeah, okay. So that was the problem. Not too bad. Not too bad. Contrary to the fact that I just got a bunch of stuff wrong. It really wasn't that hard of a problem, at least conceptually, I don't think. I think the hardest part for this one was definitely thinking about how doing this part affects what numbers you do. And I think part of that is just I didn't explain it very well. So, if you thought my explanation sucked, yeah, it's because you're probably right. Um, but yeah, I would summarize it up with another explanation of that, but I think another explanation might just make it more confusing. But basically, when you go to the x-axis, you kind of have this. And then when you go to the line y equals b, or y equals 6, things change. You have to do it kind of relative to that, right? And so you have to change the functions in the order because the bottom one kind of comes the top one, right? Or just multiply by -1. Think about it that way. But yeah, so that's how I would go about this problem. Um, I know this one is pretty challenging, I would say. Um, well, like the concept. Once you get the this part, this problem is pretty easy. Or this part. Once you get that, this problem's pretty easy. It's just a lot of work that nobody really wants to do because I think you could probably use a calculator. I think they'd probably let you use a calculator on a problem like this. Um, yeah, so I don't think you'd have to do all this, but it's nice to just go through it and remind yourself how to do it, especially because we just started being in math class again after a few months off. So let me know if you have any questions. I would not be surprised if you did. Um, and maybe at some point I'll think of a better way to explain this stuff. But yeah, it's pretty generic, rotating, solid thing, revolving solid. Um, except this. This is something you want to keep in mind. So yeah, uh, look forward to videos next week, hopefully. Let me know if you have any questions, what I could do better. And thank you for watching. Goodbye.